All right, so I think we have solved all of the audio issues and the video issues. Thank you so much for being online. There's just some problem on the audio from our side. Anyways, so just to get started with today's session is going to be divided into three parts. The first part is that we will discuss a little bit about what the Elite National Talent Hunt is about. Those of you who've been watching for a long time already know what it's about, so I will not bore you. I'll just give you a 2 minutes introduction for all the new users. The next thing we'll do is we'll discuss a data structures problem specifically in C. A lot of you were asking for how to do data structures in C, how the data structures work in C. So I'll show you how data structures can work in C, and I'll show you how you can write the solution for that in C. And then lastly, let me also take some question and answers. If you have some questions, if you have some doubts, please ask on the chat on the right hand side, and we'll be more than happy to answer you over there. Okay, so if you're here, if you're online, just type on the chat hi or hello, and we'll know that you're actually watching. Do share this video with your friends so that they also come to know about this and they can prepare for the data structures questions in Wipro Elite National Talent Hunt. And lastly, please subscribe to this channel. If you subscribe to this channel, you will get all of the updates about all the upcoming webinars. Just an announcement, tomorrow we have a marathon, a mega marathon Wipro Elite National Talent Hunt session where all of we're going to cover a lot of previously asked questions of Wipro Elite National Talent Hunt. So if you have any questions you want us to cover, let us know today in the comments or in the chat, and we're more than happy to help you out tomorrow on that. So we'll consider that as part of the marathon tomorrow. So quickly just getting started about what Wipro Elite National Talent Hunt is. The pattern for the test is going to be like this. You're going to have an aptitude test. That's a logical, English and quantitative one. If you want to prepare for this, we have over 250 plus questions on the Edyst platform just regarding this. That's logical, quants and English. We have 250 plus questions on this. If you want to prepare, you can just sign on to the Edyst platform and do it. For the essay writing, yesterday I shared an app with you. I'll again put it in the description. There's a good website where you can just type in questions and do some exercises and you will get the answer. You'll get to see the level of your essay writing, and 2 programs for coding. That's the online programming test. So those 2 programs, they're going to be 2 types. One is going to be an easy one and another one is going to be a hard one. The question we're going to discuss today is somewhere in the middle. If you have a good paper, it will be in the hard one. If you have a tough paper, then they might put it in the easy one. So that's the question we're going to do today. The questions can be done in Java, C, C++ or Python. We will be doing it today in C, but there is no advantage of C or C++ or Python. And today we are going to be looking at a data structures question. I am going to be looking at the question specifically on the Edyst pack. So Edyst Wipro pack is there. So bit.ly/Edyst_Wipro is where I will be going, and I'll actually open that up for you and show you what that looks like. So I'll be going to bit.ly/Edyst_Wipro, and once you do that, this is the page that opens up for you. This is what it is, bit.ly/Edyst_Wipro. For those of you who just want to try out 2 free modules, you can you can just click over here and try out the 2 free modules right away. In the 2 free modules, what you get is, let me show you what all you'll get. Once you sign up, this is what it will look like for you. So in the 2 free modules, you'll get these 2 modules free and the rest of it will be paid. And once you pay and unlock, you can get the remaining one. So I'm going to pick up the question directly from here. And the question I'm going to pick up is a question on stacks, which is called implement stack and its operations. So the question is basically this: write a program to implement the following operations in a stack. The operations are this: push to add elements into stack, pop to remove the elements and return the element also, peek to get the top element from the stack and return the element, is empty returns 1 if the stack is empty, and is full returns 1 if the stack is full, else it will return 0. So these are the standard operations of a stack. Now what I'll do is I'll take a 2 minutes pause over here. This is what they want us to do. Let's first revise what a stack is, right? Let's not just go directly into what a stack is supposed to be. Let's revise what a stack is, and then let's come back to this question and understand how to actually do this question. So if you recall from your first year or whenever you did your data structures, a stack is a last in first out abstract data structure, which basically means we will use these data structures to store anything such that we want the most recent object. The best way to remember is, let's say, like a stack of dishes or a stack of books, right? whenever you are stacking up books in your library or together, how will you do? You will first put the book 1 at the bottom. When you put the next book, it will be above this book. So it will be book 2, then 3, then 4. Whenever you remove the book, you are going to first remove the fourth book, right? You removed this, then you remove the third book, then you remove the second book, then you remove the first book. So the last book to go in, the last book to get inserted, or this process of insertion in a stack is called push. The last book that you pushed will be the first book to get popped out, removed. That is what we mean by last in first out, or LIFO, right? So this basically means if I were to imagine an array like this or a stack like this, let's say this is the 0th position, I introduced some stack over here called 1, some element. Then I introduced at the first position, I went, let's say 5. Then I put over here 7, right? So what's happening is, at each step, as we keep going higher and higher, whenever we push, it gets pushed to the top of the stack. So the top over here is this, right? This is the top, this is what it's pointing to. It keeps getting pushed till we reach a certain capacity. In C, we really need to define a capacity. So let's say the capacity of a stack is, let's say, something like this, right? So let's say the capacity is 5. So we can store at max 5 elements over here. 1, 2, 3, 4, 5. 5 elements. Let's say we push. So when we push 5, let's say, 5 gets stored over here. When we push 3, 3 gets stored over here. At this point, if we pop, 3 will get removed and we will get 3 as the answer. Then if we say, let's say, push 4, 4 will get pushed at this point. Let's say we push 1, 1 will get pushed. At this point, top is pointing over here. When we push 2, 2 will get pushed here, and top is not here, top is here now. And when we push 7, let's say, top again moves over here, top, 7. And now the capacity that we had, the capacity is of 5. Our top has reached the capacity. So that is, the top value right now is 4. Because we started from 0. So 0, 1, 2, 3, 4. So top value is 4 right now. So when the top value is 4, it means that we have reached our capacity. We can no longer insert more elements. So if we use the isFull method, if we do the isFull method, it will return 1 because our stack is full. If we do 0, then our stack is, if it returns 0, it means that our stack is not full. That means, let's say when the top was at 2, it still had some capacity to go, so it's not full. Similarly with isEmpty. Currently, is the stack empty? No, it's 0 because it's full right now. So it's not empty. It will return 0. It will return 1 if the stack is not empty, or if the stack is empty. So that means the top has no value, or rather the top is not even 0. It is -1. So just again recapping the entire thing for you, I quickly recap the entire stack's data structure. The stack data structure works like this. We keep adding elements from below all the way up. Initially, the top value will be -1 because there is no value there is no values in the stack. As you push, the top keeps increasing. As you pop, the top keeps decreasing. So it will keep decreasing over there. And if it's empty, the top will be -1, and the isEmpty will return 1 to us. If it's full, the top will be the top will be capacity -1, and the isFull will return 1 to us, right? Let's look at this by the code and understand how to do it. Now, let me show you some of the approach that we are supposed to do for this, and then we'll go directly to the code. So the approach for this is as follows. Second. Yeah. Right. So this is the approach. Minute. Okay, so the approach is as follows, right? Yeah, let me just approach. Okay, first is we need to create the stack. I'll show you how to create the stack, just bear with me. One is we need to create the stack, then we need to write methods for push. What does the push do? The push increases the top, or rather it checks if stack is full. If it is not, then increases top, inserts element. Pop checks if stack is empty, decreases the top and removes element, or rather first gets element and then decreases the top, right? So that's push pop. Peek just tells the topmost element. It will just tell you the element at the top. It won't remove the element. That is the difference between peek and pop. Pop will remove the topmost element. Peek will just tell us what's the topmost element. Is empty, check value of top. Let's say if top is -1, then it's empty. Otherwise, not empty. Is full, check value of top again. If top is if top is capacity -1, that means it has reached the highest possible value, which is capacity -1, then full, otherwise not full. So these 6 points are the main points you need to remember with a stack. Pushing will first check if the stack is full. If it's full, you can't do anything. If the stack is not full, then you increase the top and insert the element. If for pop, check if the stack is empty. If it's empty, you can't pop anything out of it. If it's not empty, get the element and decrease the top. So getting the element means you can remove the element. Peek, it just tells us the topmost element that we have. So it doesn't tell us anything. So just take the element and just print it. You don't need to actually remove the element. Is empty, you have to check the value of top. If top is -1, then empty, otherwise not empty. Similarly, check value of with is full. If the value is capacity -1, then we know it's full, otherwise it's not full. Okay. All right. So let's go back to the question. And now the question is a little different. Generally, in your C programming class or your data structures class, you will have to actually write the entire code. But in a Wipro Elite National Talent Hunt or any exam like this, because this one is again being conducted by AMCAT, what you'll be given is you'll already be given some code. So let me show you the C code, for example. Some C code, in fact, a lot of C code has already been written. And the question says we have to write the following operations for the stack. So some C code has already been written and we have to fill in the blanks over here and write the remaining part. Now let's understand this code properly one by one, and then let's see what we have to do about it, right? So if you can see here, they have defined the header files and all, that's fine. They have also defined a structure called stack. In C, we'll use structures to define the stack. This has a top, a capacity, and an int star r. This is nothing but an array. This is the array where all our elements will be stored. To keep a track of how many elements are stored, we have the top. To keep a track of the capacity, we have unsigned capacity. Again, this could have been int capacity or whatever, but they've made sure it's unsigned capacity. Then there is already a method defined that does the creating stack part. So that is good for us. They have already defined a method that does a create stack, which basically what it does is it returns this variable called stack. But what is this variable? So again, whenever you see such a code, don't be suddenly worried about what's going to happen. Just look at it and try to understand what will happen. What we see here is it's trying to create a pointer of type stack. So and the stack is a structure. So it created a pointer of that and it's returning that, right? But before it returns, it makes sure that the stack has already initialized to a certain capacity. It's already initialized the top to -1. Again, beginning it created, it made sure that the stack has certain capacity. Top is -1, which means that stack is empty, and it initialized the array to have the same size of the array as the capacity. So what it did was, this entire function is the malloc. It defined the array to be the same size as that of the capacity. Size stack of capacity into size of int. For those of you who are not familiar, this arrow sign is like the pointer, so it's allowing us to access the values inside that, right? So this is what it's already written. What we have to do is one by one write the push, the pop, the peek, the is empty, and is full, right? So let's do that one by one. Let's again look at the main driver code. This is the driver code. It has taking some test cases. It is taking the size of the stack and it created, so they already created a stack. What they're going to do is, when we look at push, they're going to push a number into a stack. This stack is a pointer. So what they want us to do basically is write a function called stack, called push. So let me write that function called push, right? And in that push function, what we need to do is we need to accept a, so what is it we need to do? We need to accept a stack pointer and an integer. So let's do that. It doesn't have to return anything. So because it's not returning anything, the type is void. We do push. What is the first thing that it's going to accept? It's going to accept a stack pointer. So that's stack star. Let that be called stack. And it's going to accept a value to push. Right? This is the value we are going to push inside. So that's what it's going to accept. Let's just write the method description over here, and then we'll come back to the working of it. Next, it's asking us for a pop. Pop will just expect a stack pointer. So again, but it does return an integer, that is the value to be popped. So it's going to return a, that's why it is int pop, because it's going to return an integer, right, from the structure, from the stack. It's going to get a stack pointer, right, and that's it, right? That's all it's going to get. There's nothing else that it's needs. So it has to return something, and we'll come to what it has to return. Then there is something called peek. So what peek is doing is it's going to again peek at the stack, and it's going to return a value, right? So we can roughly copy the same code or same signature of the pop, right? So we copied the same thing of the pop, and is empty is again going to return an integer, and is full is also going to return an integer, and they're all going to take a stack as a stack pointer as an argument. So let's do that. Is empty and is full. So we defined all the method definitions that we need to give. Now let's go one by one and start adding the functionality. So what does push do? Let's go back to our approach and remember what the push does. So a push checks if the stack is full. If the stack is full, we don't do anything. Otherwise, we increase the top and insert elements. So let's do that one by one. We have to check if the stack is full, right? So if the stack is full, we don't do anything. Otherwise, we do. So if is full, right, stack equal to 1. That's what we are going to do. So this is full will return 1 if stack is full, right? So it will call this is full function. So if is full stack is equal to 1, then we don't do anything, right? So we just return at that point, right? Else, what are we going to do? We are going to increase the top and add the value at the top element, right? That's what we are supposed to do. So let's do that. Stack, to access the top, we do this because it's a pointer. So stack top plus plus, we increase the top value. And what we're going to do is we're going to go to the array of the stack, right? This is the array. We're going to go to the topmost value, which is what we just increased right now, is equal to what is the new value that's to be inserted? We just defined it as val. So it has stack top val, right? So that's the pushing part. So that's the pushing part. Let's now do the popping part. What do we do in the pop? First we check if it's empty. If it's is empty, stack is equal to 1. At that point just return probably -1, right? Else, if it's not empty, what we're going to do? We have to first get the value. So int, we'll say val, let's get the value that's at the top. So stack of ARR of stack of top, right? So we got that value first. So that's the value that we got. And then we need to do stack top minus, decrease the top value, right? And then return the value. That's what the pop is going to do. What will peek do? Peek will do nothing but if it's empty, then let us again return -1 because we don't really want to do anything at that point because there is no element inside the stack. But otherwise, we just have to return whatever value is at the top of the array. Just return whatever value is at the top of the array, and that is what this will give, right? Is empty. How do we know if an array is empty or not? We check the top. So if stack of top equal to -1, right, then we return 1. That means we are telling that it is empty. Else return 0, right? Okay. And for is full, what do we check? We check if the top is equal to the stack's capacity. So what is the stack's capacity? It's stack capacity, right? So stack capacity -1, right? So if the stack top is equal to stack capacity -1, we are going to return 1. Yes, it's full. Otherwise, we'll say it's not full, right? So that's what we are going to do over here. So just again summarizing each of the ones that we did, let's actually run it and see what's happening. Does it pass all our test cases or not? Okay, let it run. All right. So yeah, what it's saying is, yeah, int pop. Okay, we have defined the spelling of struct incorrectly. So let us do struct, wrong spelling of struct from my side. Sorry for that. So we did that. Let us again run it. And again, this will happen to you at the Elite National Talent Hunt. Do not worry. The more compilation errors you get, the closer you are to your answer. So you will get closer to the answer once you actually get it. So in function push, implicit declaration of function is full. Okay, so we have tried to use the is full and is empty function over here. Probably we need to define the is full and is empty above the push and pop, right? Let us try to do that, because yeah, now let us try to run it. And if that doesn't work, then I'll just pull those two functions inside the push and pop, right? So that's what we'll do. Okay, by the way, 112 people are online right now. That's brilliant. Okay, let us see what the issue is. Okay, so there is a small spacing issue over here. Okay, how would we? All right, so that is because of the template. So I'll ask them to get that fixed. But yeah, basically this is working at this point. So let me just 1 second submit it. Okay, yeah, there's something wrong with the template. So basically speaking, our code is right. There's a small issue with the template, that is over here, where the spaces are not given correctly. So if you can just check the difference between the expected output and that, what you see is there's supposed to be a space after is full, but over here there is no space that is given in the template by them. So that's fine. We'll actually get this fixed so that when you practice you will get it. But if you look at it, our code is pretty much, apart from the spaces, our code is correct. So that should be fine. So that shouldn't be a problem. In fact, what we can actually try is probably adding a space of our own. No, that will not work because there's a space over here, so we can't really add the space amongst ourselves. We'll need to just update that. So we'll make sure that this is updated so that when you are practicing you get it. So let me just recap what this question is about and how we went about doing it. There was already some code given to us by them, and so this will happen to you in the Elite National Talent Hunt, where you will be given some code, and given that code you will need to so you will need to fill in the blanks or fill in that part. So understand the code thoroughly, that what's actually happening. In our case, we didn't need to create any stack. The stack was already created for us. And similarly, if the driver function was already written, and again in the driver function some spaces are missing, so that's a genuine issue. If you get something like that in the test, don't be worried. Make sure that your logic is right. They will update the driver function and they will make sure they run your code again so that it works out well, right? So that is that. The second thing to remember here is we saw that there was an error if we don't define the functions in the correct order. When we were trying to do is full, the is full was not yet defined because it has to come before the function. So if you're going to use is full and push, you have to define is full above push. So that's one of the issues we saw. But basically, to solve the stacks question, we broke it down into 6 things. Number 1, creating the stack, which the question was already doing. Pushing, we have to do 2 things. Check if the stack is full. If it's full, increase the top and insert the element. Pop, check if it's empty. If it's not empty, then only we get the element and remove it. Otherwise, we just return -1. Peek, it will just tell us the topmost element. So we check the topmost element by checking the top value. Is empty, we check the value of top. If the top is -1, that is it's below, that is there is nothing in the stack, that means it's empty. Otherwise it's not empty. Same thing with is full. We check the value of top. If the top is capacity -1, that means it's reached the highest possible value, then it's full. Otherwise it's not full. So that's how we would do a data structures question. That's how you should expect a data structures question in your Elite National Talent Hunt. So I'll just wrap up, and if you have any questions, please ask us on the right hand side. But on the chat, you can ask us on the chat or in the comments. But this is generally how you would be asked a data structures question. Because a data structures question is so big, they will make sure that they've already given you some driver code, and you're supposed to mainly fill in the blanks and figure things out by yourself. This is how you do a stacks. Similarly, if you want to implement a queue, you can go online on the Edyst platform and implement the queue functions as well, the queue question as well, and you'll get that too. So do practice this, do practice the stacks and queues questions. Make sure that you are familiar with the stacks and queues, familiar with this whole pointers and structures and things in C. That is very important. And make sure you go and practice this question on the Edyst platform. We will make sure that the template is corrected for you so that you can go and practice this correctly. A reminder for everybody that tomorrow we are doing a mega webinar marathon where we'll solve all of the previous year's coding questions. If you have any specific coding question that you want us to solve, we will definitely solve it. So put that in the comments, put that in the chat, and our team is online and we'll pick that up. For any questions or any queries, you can always reach out to us on the WhatsApp number that's over here, and also on the email ID. Do reach out. We read all of your emails. If you have any emails or questions, you can reach out to us. And sign up on the Edyst Wipro pack. You can reach out to me on the Edyst platform, chat with us, and get any of your doubts solved also. So thanks everybody for being online. I believe there are no questions today. So if you have any questions later on, you can just WhatsApp us and email us on this number. Thanks so much for joining everybody today. Make sure that you share this video to all of your friends who are applying for Wipro. This will be very helpful for them. And also subscribe to this channel. The more you subscribe, you'll get a notification about the upcoming webinar and the webinar tomorrow, which is the mega marathon webinar. It will be a very long one, but we'll cover all of the previous year's questions. So do ask us any of the questions that you want, and we'll cover it tomorrow. Thank you so much everybody for joining, and see you all next time tomorrow for the marathon webinar on Wipro Elite National Talent Hunt. Thank you.